Hi, I'm Nick Raboy from MongoDB. In this tutorial, we're going to see how to build a simple .NET Core application that communicates with MongoDB using basic CRUD operations. So create, read, update, and delete. So up on my screen, you'll notice that I have MongoDB Atlas loaded. That is a prerequisite to starting this tutorial. So if you need help getting started with Atlas, go ahead and check out one of the previous tutorials on the Dev Hub, or check out a previous tutorial on YouTube. Now, in addition to having MongoDB Atlas ready to go, we will be using a sample data set. So if you have MongoDB Atlas loaded up on your screen, what you can do is click on the ellipsis menu for your particular cluster, and you can say load sample data set. In particular, we're going to be working with the sample mflix database and the collections. However, we're not actually going to be working with those collections. We're just going to be using them as the theme of this particular example. So if I click on Browse Collections within MongoDB Atlas, and then I click on Sample mflix, you'll notice that I do have a playlist collection that is not part of the Sample mflix dataset. So this playlist collection is going to hold playlists for a particular user about movies that they wish to watch. Now, this is all fictional data that we're going to be working with, but like I said, it's themed around the data that you might find in the sample mflix database. So with that in mind, let's go ahead and crack open our favorite IDE of choice for developing .NET applications. In this particular example, I will be using Visual Studio Code, but you can use whatever you feel the most comfortable with. Now, if you're using Visual Studio Code like me, go ahead and create a new .NET Core console application. If you do, it's going to look something like this. We have a program.cs file as well as a CS project file. You can validate that your .NET Core is working correctly by going to the console and saying .NET run. If everything goes smooth, it should say hello world in the end. Now what we want to do is we want to install the MongoDB .NET Core driver inside of our application. So what we can do is if we're using the CLI like I am, we can say something like .NET add package mongodb.driver. And this particular command is going to find the latest version of the MongoDB driver for .NET. If you want to specify a version, you could specify a version in this command. It's totally up to you. If you're using Visual Studio rather than Visual Studio Code, you could use something like NuGet to handle your package dependencies as well. But there is no official NuGet extension for Visual Studio Code, hence why we're using the CLI. You can validate that MongoDB installed correctly by going into your CS project file, and you can see that there is an item group reference for the MongoDB driver, and in this case I'm using 2.14.1. Alright, so let's go ahead and get down to business when it comes to developing this application. To start things off, what we're going to do is we're going to wipe out the code that currently exists in this particular program.cs file. We're going to replace it with using mongodb.driver, which is what we had just installed. And we're going to specify a Mongo client with an appropriate Atlas URI string. So we're going to say Mongo client equals new Mongo client. And we're going to specify a MongoDB Atlas URI string. Now to get that string, let's go ahead and go back into our MongoDB Atlas dashboard. We can click on the Atlas tab. And for the particular collection that we want to connect to, we can say connect, and we can say connect your application, and we can copy the string for C#. Let's go back into our Visual Studio Code or whatever IDE you're using. Let's go ahead and paste it in. And let's replace the username and password with the ones that we wish to use to connect to this particular cluster. I've gone ahead and created the following. Now you'll notice that I do have a typo when it comes to my code. I have user ring, it should be using. So let's go ahead and fix that. And let's go ahead and save it. And those errors should go away. So we have our MongoDB client. Let's go ahead and now list out the available databases that we have for this particular user. So we can do that by saying list, because we're going to say that we want to print out a list of strings. So we're going to say string, and we're going to say databases. Now this is totally optional. This is just a good way to test to make sure that everything's working correctly in your particular application. So we can say client.list database names, and we can say toList. And to print that out, we can just say for each. We can say string database singular in databases, so our list. And we can say console dot write line, and we can say database. Let's go ahead and save it and run it. So let's go back into our terminal and let's say .NET run. You'll notice in this particular example that I got an error. I got an error regarding authentication. Now, looking back at line 3 when it comes to my connection string, I did notice that I have the correct username, but my password is incorrect. So let's go ahead and fix that. And I'm going to run it again. This time around, instead of throwing an error, we got our list of databases for our particular cluster that this user has access to. So that's a good sign. So what we can do is we can erase this code that we had just created, leaving the Mongo client alone. All right, so the next step is to get down to business. What we want to do is we want to be able to do CRUD on our database using this particular application. And we could use BSON documents, which is a class that's part of the .NET driver for MongoDB. But what I like to do is I like to use actual classes that I can map to MongoDB documents and fields. So that way I can use the objects within .NET like I would any other object, and then trust that it works fine when it comes to MongoDB. So let's go ahead and save what we have, and let's go ahead and create a new file. So what I'm going to say is I'm going to say new file, and I'm going to call this one playlist. And this is going to be playlist.cs. So in this particular file, let's go ahead and say public class playlist, and we're going to find each of our fields that we wish to use not only in our .NET Core application, but within our MongoDB Atlas database and collection. So the first thing that we want to do is we want to say public string username. So we're going to have a user for this particular playlist. This username is going to have a get and set method, and we want to default it to null. We want to allow nulls for this particular field. Now you could default it to just an empty string, but that may further complicate things down the line for you. It really depends on if you want to have empty strings or nulls, etc. So that's for you to decide, not for me. What we also want to do is we want to have a list of movies for this particular playlist. So we can say public list string, and we're going to have items or movie IDs or whatever you want to call them. And we're going to have get, set, and we also want this to be nullable. So we have two fields. One field that we absolutely must have when it comes to our MongoDB documents is an ID field. Now you can choose that to be a string, or you can choose it to be an object ID. If you want MongoDB to decide your IDs for each of your documents, you might want to go ahead and use an object ID hash, and it'll do that for you. That's what we're going to do in this particular example. To do that, what we need to do is we need to say using mongodb.bson. And then for this particular field, we're going to say public object ID underscore ID, and it's also going to have a get and a set, and we don't need to default that as null or etc. because the object ID or the underscore ID is always going to exist when we're working with our documents. Now let's get some further details about this. So if we left it as is, the .NET driver will automatically map our class fields to our MongoDB collection and documents. So ID, username, and items will be saved within our documents as is, exactly how they look. And we're going to see how to play around with that in just a minute, so that way there's the examples where maybe we don't want the field names to be mapped exactly to the document field names, because maybe the document existed prior, etc. There could be numerous reasons. We're going to see some alternatives, but for now, let's just leave it as is. So let's go back into program.cs, and we're going to start the next step. So the next step will be for creating data, because we're going to assume that our collection is empty and that we need to create a new document with our data. So what we can do is we can say var, we can say playlist collection, we can say client.getDatabase. We're going to specify sample underscore mflix, and we're going to say get collection. We're going to specify that this collection is of type playlist, and we're going to call it playlist. So now that we have a handle to our collection that we want to use, let's go ahead and create data to save to it. So we know that we have a string for a username, and we have a list for our kind of playlist of movies. So let's populate that list first. So we're going to say list. We're going to say movie list equals new list. Let's go ahead and add data to that list. We're going to say movie list.add. And let's just go ahead and say 1, 2, 3, 4. Remember, we're not going to be worrying about real data for this particular example. It's just inspired by a movie playlist. But it could be very useful to you when actually working with this particular sample collection and sample database. It's just a starting point for us. So we have a list. Now let's go ahead and say playlist collection dot insert 1. So this will insert a single document into MongoDB. You also have the option to use insert many. It's totally up to you. We're only going to be inserting one single document, so insert 1 works for us. So what we're going to say is we want to create a new playlist, and we want to be able to specify our fields. To do that, we're going to need to go back into our playlist.cs file. We're going to need to create a constructor method, so that way we can actually preload that data. So what we're going to say is we're going to say public playlist. We're going to specify that the user can pass in a username and a list of string. And this is going to be our movie IDs. And we're going to default those values. So we're going to say this.username equals, and we're going to say username. Likewise, we're going to say this.items equals movie IDs. So let's go back into program.cs. And now we can say that we want to add maybe, let's go ahead and say Nick Raboy as the username. And we're going to say that we want to add our movie list as the movies for our playlist. And I'm going to save it. Now what I'm going to do is I'm going to clear my terminal, and I'm going to say .NET run. So it ran. Let's go back into our MongoDB Atlas dashboard, and we're going to say browse collections. We're going to say sample mflix. We're going to say playlist. I have 2 documents in here, the nraboy document that was already there, and then we have a new document. The username is Nick Raboy. We have an object ID for the underscore ID, and we have an items array of string where we have one item, which is 1, 2, 3, 4. So this is as we expected it. So you'll notice that each of the fields actually maps directly to the fields that we have put in our playlist class. So remember, I said that we can actually look at something a little differently now. So I'm going to delete this. I'm going to go back into Visual Studio Code. I'm going to go back to my playlist.cs file. And now we're going to use the scenario, well, maybe our field names in our document aren't going to match up directly with the field names in our playlist class. So to do that, let's go ahead and add a new import. So we're going to say using mongodb.bson.serialization.attributes. Now let's say that the username is username remotely. But let's say that we want to be working with it locally as user. So what we're going to do is we're going to say bson element, and rather than having the local field user, let's go ahead and make the remote field user. So we're going to say user. So our document will have a user field, but our local class will be used as username. And just like that, if I were to save it, and if I were to run this again, so I'm going to say .NET run, and if I go back into my Atlas dashboard and I refresh, you can see now that the field is user instead of username. And that's because I changed the mapping for this particular field. So you have options. Now there's a lot of different things that you can do when it comes to these object mappings in these classes. I won't go into them for the scope of this particular tutorial, but it's worth checking out the documentation to see what you can do. Now what I'm going to do is I'm going to change this back into username. So what we're going to do now is we're going to move on to the next step. The next step is going to be reading our documents. So let's go ahead and do the following. Let's go ahead and leave the insert 1. And this time around, what we're going to do is now we're going to do a find operation. And to do a find operation, you actually need to create a filter that filters on the documents that you wish to find and return back to the client. So to do that, let's go ahead and create a new filter definition. This filter definition is going to be of type playlist. We're going to call it filter. And we're going to use builders. We're going to use a Fluent type API. So we're going to say playlist. We're going to say .filter. And for this particular filter operation, we're going to do an EQ, so equals. Now there are other operations that you can use. You can use greater than, less than, things like that. Depends on the type of data that you're working with and the type of filter that you wish to do. But for this scenario, we're just going to say a particular field has to equal this particular value. And for that, we're going to say username. And we're going to say the username has to be Nick Raboy. So we have our filter definition. The next step is we want to do that find operation using that filter. So we're going to say list. We're going to return playlist as the list type. We're going to say results equals playlist collection dot find. We're going to pass that filter in, and we're going to say to list. And just like the example where we listed out the database names, we're going to loop through the results and we're going to display particular values about it. So we're going to say for each, we're going to say playlist result in results. And we're going to say console.writeLine. And we're going to say that we want to join our array. So rather than trying to loop through again each of our array elements, which are fictional, we're going to say the following. We're going to say string.join. We're going to join with comma delimited. And we're going to say result.items. So what we're doing is we're taking that array or that list of items, we are merging it into a string, and we're separating each item by a comma. So what I'm going to do is I'm going to save it. I'm going to make sure that I don't have anything inside of my cluster for Nick Raboy at the moment. So I'm going to delete it. I'm going to go back to Visual Studio Code. I'm going to run it. And after it ran, it just printed out 1, 2, 3, 4 because I only have one item in that array. So it did a create and then it did a read. So let's move along and start doing an update. We're going to leave all the code that we have as of now, but now we're going to update our data so that way we have maybe another item in that array. Let's go ahead and do the following. We're going to create another definition. We're going to use the same filter definition that we saw on line 12, but now we need a definition for actually updating the data. So when it comes to updating, we have a filter to find the documents that we want to update, and then we have an update definition for the criteria that we want to update within those found documents. So we're going to say update definition. The update definition is going to be of type playlist. We're going to say update equals, we're going to use builders again. We're going to say playlist. We're going to say dot update, and we're going to provide an operation that we want to do. Now, there are a lot of different operators that we can choose from, just like when it comes to filter. You should definitely look at the documentation for this. For this particular example, I'm going to use add to set, and I'm going to add a string to the set. So add to set adds a new item to an array field, and if that array field already has that particular item, it's not going to add it. So it's going to handle duplicate IDs or duplicate values for us. There are other commands that will allow you to use duplicates, but this particular add to set will not allow for duplicates. So I'm going to say items, because that's the field that we're going to be working with. And I'm going to add a new ID called 5678. Now that we have that, we can say playlist collection dot update one. So we're going to update a single document. We could use update many because maybe our username field is not unique and we can have users that match up. We could say update many and it'll update all of those versus update one, updating the first. We're going to assume that it is unique. We didn't set up anything that made sure of it being unique, but we're going to assume it is right now. So we're going to say update one. We're going to provide the filter. We're going to provide the update. And if I ran it, it would then add this new item to the list. And we're going to validate that before we run it by actually printing out another find. So we're going to copy lines 14 through 18. I'm going to fix lines 24 because I've already declared the results variable. I'm going to save it and I am going to run it. And before I run it, I'm going to go back in and I'm going to refresh because I don't have a delete yet. So I'm going to delete it manually because I don't want to handle duplicate usernames for this particular example. I just removed it. Let's go back into our code. Let's go ahead and say .NET run. And we should see 1, 2, 3, 4 alongside 5, 6, 7, 8. And we did. So we know our update worked. It printed out first before it did the update, and it printed out after we did the update. This leaves us to our final delete operation, which is going to be actually quite simple in comparison to the update, even though the update wasn't that complicated. So let's go ahead and use our same filter that we did for our first step. So the filter that we used for finding a document. What we're going to do now is we're going to say playlist collection dot delete one. And like with the other commands, we could say delete one or delete many. I'm going to delete one. I'm going to say filter. I'm going to save it. And before I run it, what I'm going to do is I am going to delete that pre-existing document. I'm going to go back into Visual Studio Code. I'm going to clear it. And I'm going to say .NET run. And it printed out our first one. So before the update, it printed out our second one. And if I went into our Atlas dashboard and I were to refresh, that document should not show up. So that document no longer shows up because the delete operation is removing it at the end. So I'll just review a few things inside of this code to clear things up. So the first thing that we did was we installed the driver and we defined our MongoDB Atlas URI that we got from the MongoDB Atlas dashboard. Make sure that your username and password is correct and that you actually have access to the database and collections that you're trying to use. After we did that, we defined our playlist class. This playlist class for this particular example maps directly to the fields within MongoDB, but we also saw how to use bson element to map to different fields based on what we actually defined for the local field name. Now, if we went back into program.cs, we did a create operation first, followed by a read operation. Then we updated that same document, and then we finally deleted it. And we did that all within 30 lines of code, so not too bad. Now, this is just a console application, which could be very valuable for your particular use case, but you could take this code and start building web applications as well. So if you like this video, please take a moment to hit that like button on the video within the MongoDB YouTube channel, and then subscribe to the MongoDB YouTube channel. It'd be greatly appreciated. I hope that you found this tutorial valuable, and I hope that you enjoy the rest of your day.